In this session, we'll hear from Miriam Friedel, Director of Software Engineering, Center for Machine Learning at Capital One. She'll discuss how to create advanced analytics services for your company and business partners on top of CDP. Don't forget to drop your questions in the Q&A panel and we'll answer them at the end. Over to you, Miriam.
Hi, everybody. My name is Miriam Friedel, and I am a Director of Software Engineering at Capital One Center for Machine Learning. And today I'm going to talk about standardizing the model development process. So I'm going to talk a little bit about things specific to Capital One, but I'm also going to talk about the model development process more generally. Okay, so let's move on, and I will talk about our agenda. So first, I'm going to give a little bit of information about me and C4ML. I'm going to talk about the machine learning lifecycle, and I'm going to talk about tracking iteration, why this is important, and then I'm going to talk about tracking iteration, how you can do it. And I'm going to talk specifically about an open source library that my team has built called Rubicon ML, and we would love your engagement, feedback, using of the library. So I'll talk a little bit about that at the end. So a little bit about me and a little bit about C4ML. You can read my bio on the website for the summit, but I have a PhD in physics, and I've been engaged in a number of different technical pursuits throughout my career, including consulting, neuroimaging, software engineering, and really for the last almost 7 years, I've been pretty much in the data science machine learning space. So another thing I'll note is I'm going to use the words data science and machine learning interchangeably throughout this talk. So even though I know that's a little bit imprecise, I hope you'll bear with me. So the Center for Machine Learning, we are a center in Capital One. We've been around, I believe, since about 2015, 2016, and we're very fortunate that our CEO, Rich Fairbank, is very forward-thinking, and he has identified machine learning as part of our technology transformation, which has been ongoing for a number of years now. Particularly notably, as Capital One, we have divested ourselves of all of our data centers, and we are now just 100% cloud environment for our compute and for our data. But the Center for Machine Learning was really formed to help fulfill this need and bring machine learning expertise to all of Capital One. So within C4ML, we build platforms, we build tooling, we have consulting engagements throughout the rest of Capital One. So we really serve lines of business and card and risk and global finance throughout the organization. And it's a really exciting place to work. So I'm going to talk now about the machine learning lifecycle. This is very linear, and spoiler alert, I think a lot of you know that this is actually not a linear process, but let's just pause and talk through some of the components of this process. So the first thing you need to do when you're building a machine learning model is you have to define the business value. Like, why do I need to build this model in the first place? What do my business stakeholders need? Am I saving money? What am I doing? Then once you've done that, you need to say, okay, now that I've identified the business need and the problem that this model could potentially help solve, where's the data, right? I need to access this data. Where does it live? I need to explore it and understand it. And particularly in places like Capital One, we're very highly regulated. And so data privacy is a big concern. Data security is a big concern, right? So making sure that, the modelers have access to all the data they need to build models. Then you need to explore the data. You need to kind of like wrangle it, as I like to say, rummage around, understand what's going on. Can I build some features, right? Do I need to combine, various different raw data sources to build multiple features? You need to do that. Then there's exploring modeling techniques, tuning hyperparameters. You're not just going to build a model one time. So for those of you that are used to writing Python code, it's not just one fit and one predict and you're done, right? It's a very iterative process, and you need to be pretty rigorous about your cross-validation, which is step 5, evaluating the outputs of this model. And then you need to also document, you need to gather governance and approvals. This is another part of Capital One. We have something called the Model Risk Office, which I'll talk about in a few slides, who is responsible for making sure that our models are explainable, mitigate risk to our customers, mitigate risk to Capital One. Everything is done fairly and explainably. And then eventually, once you've built your model, you have to put it into production and monitor it over time and identify when you need to retrain and rebuild. So there's really a lot of stages in this process. And as I said before, it's actually not linear, right? Like it is not a linear process. And I think one thing, this diagram, which I really, really like, this is the Microsoft Team Data Science process. And it really shows, I think, the iterative nature of this, how business understanding and modeling, they inform each other. Data acquisition and understanding, informs the business understanding, right? In the previous slide I had at the very beginning, you define your business problem. And that's really important. But as you go through the modeling process and as you evolve and try to, understand your data and explore it, that helps inform your business understanding. And so I'm going to give an example of this, not from my time at Capital One, but from when I was a consultant previously at Elder Research. We were working with a large software company. And this company came to us and said, we really want to do a user segmentation model to better understand our users and market to them more effectively. But we don't want to do it based on traditional marketing metrics. What we want to do is we want to base it on people's usage of the software. And so, they gave us all of these logs, terabytes of data to understand what people were doing. What were they clicking on throughout the software, and how could we use that to inform the segmentation? So the first thing they said is, there's probably going to be several hundred commands that you're going to see in the data, and that's what you're going to want to use. As far as they were, concerned from their understanding of the tool and their understanding of the software itself, there would only be a few hundred commands. Well, we went into the database and there were over 10 million distinct commands. So we went back to them and said, hey, there's 10 million commands in this database. And they were like, that's really interesting. So we were able to work through this problem together and understand the discrepancy between what was in the data and what they had initially thought was in the data and asked us to do. But I think that's a really great illustration of how the business understanding and the data acquisition and understanding and the modeling, how it's really this sort of cyclical evolving thing, right? And it's the same thing as well when you look at the deployment piece down at the bottom, and seeing how do these models behave sort of in the wild, as I like to say. So one great example that you can think of is we've just experienced COVID, for the last, 15 months or more, even for some of us. And that has changed the data that we've been collecting sort of universally. And so if you have models that have been built before COVID and they're, you're running new data through them and scoring them, right? Like the models are going to give you different results than maybe they did 15 months ago, right? And so that's going to then inform like, hey, I need to retrain this, or hey, I need to rethink how people are behaving. So it's really like a very living, breathing thing. And the part I want to focus on, the living, breathing part, is the model build process itself. So I just gave an example of data understanding and business understanding informing each other, but I want to talk about the model build process. So this is really, I think, how it goes, right? So you start at the top, you're exploring some data, and you find an initial set of features for your model training. You're like, this set of features looks great. Then you're trying an initial modeling technique, right? Maybe you're using a random forest. You're doing a bunch of different, parameter optimization. You're looking at a particular metric. It might be accuracy. It might be precision. It might be recall. It might be F1. It could be any of these things. And so you do this initial modeling technique with these features, and you're like, it looks pretty good. I'm going to do some more runs. And then you're like, you know what, random forest, that's not really what I need. I need to try XGBoost, right? So now you have a different model. You have a different set of parameters, right? And so you're going through this whole process again with to compare and contrast, right? You need to understand what's the best model to solve this problem. Then you get maybe to the end of that and you're like, actually what I really need is a different set of features. I've completely overlooked something that would be very, very impactful for this model. And, something from one of the credit bureaus, for example, or, particular user data that you might be using, to inform your model. And so then you have to go back and do it again. You have to go back to the source data. You have to pull more data. You have to pull different data. Maybe you don't have enough history, right? So it's a very iterative process. But as you're going through this, you're generating all these little benchmarks, right? For this set of features, I got this result. For this set of features, I got this result. For this set of features, I got this result. And it's actually really, really important to track this iteration. So why do you need to do this? Well, if I'm leveraging machine learning to make a business decision or impact a customer, tracking this is essential, right? So I mentioned earlier the model review office, or the model risk office rather, at Capital One, right? Like if I've built a model that's going to approve or deny somebody credit, or if I've built a model that's going to determine like how much credit to give this person when they apply for a credit card, I need to be able to explain the result I'm getting. So if I apply for a credit card at Capital One and I'm declined, they need to be able to tell me why I'm declined. So this gets into model, explainability, which is, that's a subject for a different talk. But when you think about when the model risk office has to review and say, yes, this is a good model, they need to understand why we chose model A as opposed to B, C, D, E, F, G, right? So tracking this iteration and tracking all of these experiments is really important because then you can provide this information in a transparent manner. It enables fairness and reduction of bias, again, the mitigation of risk and ensuring reproducibility. So if I have built a model and you are my model risk officer and you need to understand what I did, you should be able to reproduce that model soup to nuts. And if I'm giving you these little checkpoints and giving you this logging information along the way, that's going to make it a lot easier for you. So why is this hard, right? Why is this a hard thing to do? And I talked a little bit about this in the abstract for this, if any of you read my abstract, and it's about the evolution of machine learning and data science, right? Like I remember when I started in this field and I was, working on that customer segmentation model, right? We were doing all of this experimentation in R, and it was just experiment after experiment. We were all on individual laptops, and like eventually we got to the right model, but there was no tracking of the whole process, right? And the thought of like, I need to operationalize this and put this somewhere, right? It wasn't high on our radar. And I think that's changed, right? I think now as a community, we understand how important this is, but this requires a behavioral change, right? Like from just sort of scientifically like exploring and going through, right? Like making sure what you're doing is transparent and really borrowing some of the best practices from software engineering. There's this intersection between data science, machine learning, and software engineering. I call it an overlapping Venn diagram often. And so making sure that we as data scientists, like people who build machine learning models, we're adopting these best practices, and that requires a behavioral change. Competing technical priorities, which I just alluded to when you're talking about building the model versus operationalizing it, right? Like when you're building a model, you need to hit that metric, whether, again, accuracy, precision, F1, et cetera. But if you're building, say, a platform or you're building an app, right, you have latency requirements and you have other requirements, right? And so marrying those two things is hard. And then the final thing, I'm reading this slide from right to left instead of left to right, is lack of good tooling, right? Like I think I've been at a number of different organizations with really smart people who have tried to figure out what's the right process to do this. And I think it's hard, but it's also necessary. And so what I want to spend the last few minutes talking about is Rubicon ML, which is an open source Python library that my team has been working on for a couple of years. So I've only been at Capital One since last July, and my team has actually been working on this for quite some time before that. And we're very excited because we've just been able to open source it, as I mentioned at the beginning. So y'all can come in and use it and give us feedback. But what Rubicon does is it allows you to track this experimental data over time in a way that's repeatable, it's searchable, you can visualize and filter this experimental data, you can share it. And so all of those things I talked about that are both necessary and hard, Rubicon ML can help you with this. I also have, all those logos at the bottom, right? We're integrated with Git. So you can tie your experiments to a Git repository with scikit-learn. So if you're familiar with the scikit-learn API, which I think most people building models today are, and if you use Prefect for workflow orchestration, we leverage Prefect as well and are compatible with that. So right now I'm just going to talk us through a few code snippets for the scikit-learn integration, but then I'll show you our URL at the end. So you're welcome to go there and explore for yourself and explore some of the other examples. So logging, right? It's very easy to instantiate a project in your existing code. You just pip install it or conda install it, and then boom, you're there. From Rubicon ML, import Rubicon, you create a Rubicon object and you create the name of your project. And one of the things I love about this library is it's very, very flexible, right? You can name things what you want. You have a number of different, you can log metrics or you can log parameters, but it's really up to you. And so you can really customize it for whatever type of model you're trying to build. So here, for, a particular project, you can log experiments, you can log specific parameters. So here, if you were doing, we're doing some PCA or we're doing, some Gaussian modeling, right? And we can, log whether or not something is standardized, number of components. This particular example is for wine classification, which is a pretty standard scikit-learn data set. So this is just an example, again, available on our website. And then you can also log metrics, right? So in this particular case, we're using accuracy as our metric for a classifier, but it really could be anything you want. Like, you have the flexibility to define that. It also makes it really easy to publish and share log data. So you can publish an intake catalog and then somebody else could consume it. So I talked earlier about the importance of reproducibility and being very transparent in your modeling. And this is a way to do this. And one of the things I also love about this is that I think as model builders, we're so used to working in code, and this was designed to really just fit right into your existing processes. And then finally, we also have a dashboard that we can leverage and you can run locally to look at examples of your metrics, right? So in this particular case, we're showing a parallel coordinates plot and we're showing a table. I know it might be a little bit hard to see on the screen, but again, there's an example of this on our GitHub repo. So you can walk through these different models, look at any tags you've made. So in this particular case, we have a metric that we've included in the code to say, like, you know, if the accuracy is above a certain amount, we call this a success. If it's below, then we call it a failure. So this, when we get back into what I was talking about earlier with having to explain, why did I choose this model and not this model? Well, here you have an easy way to visualize that. You know, you can show the number of components, you can show accuracy. So there's really a lot of flexibility with this tool. And then finally, here's the GitHub repo. We would love feedback and suggestions. You know, we have the team sort of actively working to improve this all the time, and we love your feedback. So I want to thank you all for your attention, and I would be glad to take any questions that you might have.
Awesome. Thank you, Miriam. That was definitely a very great presentation. I know we've had a couple questions come in from the audience. So the first one I do have here is, a lot of tracking now exists in systems like MLflow. Did you implement your own?
Yeah, so that's a great question. Also, hey everyone, thank you so much for coming to this talk. So yes, we built Rubicon ML as a library. So MLflow is a great example. There's a lot of great tools out there, but it's tied to Databricks. And so we wanted to build something that was not tied to an enterprise paid service like Databricks. And our goal was really to be extensible and support as much as possible, various file systems, anything FSpec can support, designed to be easily integrated into the Python ecosystem. That was really our focus, and tying model results directly to model code. So, so it's a great question. It's a question we get a lot about MLflow, and that's certainly, like, you know, there's a lot of great tools to do this, but this is why we built this particular one.
Awesome. And then one other is, how well does this scale and when does it become an issue?
Yeah, so that's a great question. So we actually, this is something we're actively working on to do better benchmarking around this. So we've shown that this can scale pretty much about like you would expect for local file system logging. And you wouldn't really want to run like tens of thousands of experiments on your on your local laptop anyway, although, you know, in this day and age, I think a lot of us are in the cloud. And so for scaling, we recommend S3 with the asynchronous or concurrent logging feature, and that really helps you to scale. So one of the things we're excited about is we've open sourced this tool and people are using it, is to sort of push the boundaries with more use cases. So we can get better use cases to solve the scaling problem, because I think in our experience, that tends to work better than if you're using something like synthetic data.
No, that's really cool. One other one we do have here is, what are common pitfalls you see with new users adopting Rubicon ML?
That's a great question. And I think the biggest pitfall is, honestly, you know, I talked about change management in the talk and processes and trying to reorient people's thinking, like, oh, I really should be doing this, and it's actually, you know, maybe not that much of a heavy lift. And so that's sort of, I would say, thing number one. I think thing number two is not adopting the automatic Git integration. So it's really critical to make sure that whatever model experimentation you're doing is tied to the code that you've written. You know, things like what version of scikit-learn is just as important as what is actually in the code, because that's going to impact your model results. So really adopting the automatic Git integration is one. And then another is it sometimes takes a while for people to properly tag their experimental data to facilitate easier searching later on. But I think that's not, that's sort of when you're using any tool like this, is really flexible. It takes a while for you to figure out what's going to work for you. So, the tagging, I would say, is another one.
Very interesting. And then one other, what is the difference between this Rubicon ML dashboard and ML Flow?
That's a great question. So I actually have not, like I mentioned, we've gotten a lot of questions about ML Flow, but I personally haven't spent a lot of time using it. So I'm actually going to punt on this question, which is not great, I realize. But I think like one of the things that I would say is if you are an ML Flow user and there's a feature that you really like or something that you feel like is really essential to your model building process, we would love to hear about that. If you use Rubicon or you play with it and you're like, hey, this dashboard doesn't have this, but it does have this other thing. So we would love to hear about that. But I think in terms of specific differences between us and ML Flow in the dashboard, I haven't spent enough time with ML Flow to really dig into detail.
No, still really cool. Thank you. I know that's about all the time we do have in terms of questions, but thank you so much again. It was definitely really great having you and great hearing your talk.
Yeah, no, thank you so much for having me. And definitely, please, if you have any further questions, I'm available on LinkedIn. And please go to our GitHub repository, and we would love to engage with you there as well. So thank you.
Awesome. Well, everyone, do be sure to check that out. I also want to thank everyone for taking the time today to join the Data Point Summit here for Healthcare and Finance by Grid Dynamics. We've definitely heard many exciting talks on how data is being leveraged in these industries and how it's constantly improving quality care for patients in healthcare and also how it's improving systems in finance. And then I also wanted to remind you that you can continue to access our virtual lobby to view sessions, and all the talks will also be available on demand starting 2 hours after they were live. And then you'll have ongoing access for 2 weeks to catch any talks that you may have missed, or even if you want to rewatch them. So if you would like to view the supporting slides, you can also find those in the resources tab of the console, and you'll be able to check those out there. So again, thank you to all of our attendees and for all of our speakers for taking the time to be with us. We definitely hope you feel more knowledgeable and supported to continue to innovate in these industries moving forward. And we definitely hope you have a wonderful rest of your day. Thank you again, everyone.